Section 2.3, we're going to rewrite formulas and solve literal equations. So our I can statement, I can solve both simple and more complicated literal equations for a given variable. First, we're going to have to come up with what the word literal means. We'll get to that in a minute. First, we're going to look at just solving some equations. And so to do that, we're going to look at some regular polygons. Here, this table below shows perimeter formulas. Again, perimeter is the distance all the way around. Okay. Distance all the way around. So meaning if I was going to walk around this guy, if I was going to walk around this triangle, what would be the total distance that I travel if I'm going to walk all the way around him? Okay, so that's perimeter. So here's for some regular polygons. Okay, a polygon, if you don't remember, a polygon is a closed figure, meaning once you're inside, if I have this little person inside here, they can't get out. Okay, it's got a strict inside, a strict outside. So it's a closed figure made up of line segments. We call those line segments sides that intersect only at their endpoints. So the only place that they meet are here at those endpoints. A regular polygon, so the word regular, we use the word regular when it comes to polygons, is a polygon whose sides all have the same measure, meaning the lengths of all the sides are the same. So the length of this side would be the same length as this side, the same length as this side. When we're dealing with a three-sided figure, we call that an equilateral triangle. Instead of using the word regular triangle, we use the word equilateral. If it's a four-sided figure like here, four-sided, that's a square. A square is a regular polygon. And then here we have a regular pentagon with 5 sides and a regular hexagon there with 6 sides. Okay. And whose angles all have the same measure. So all the angles have to be the same as well. So like this angle in here is going to be the same as this one in here, and this one in here, this one in here, so forth and so on. All those angles are the same. Okay. So here we have some equations. To find the perimeter, the distance all the way around this equilateral triangle, we just take the length of one side and multiply by 3. Since all 3 sides are the same, they're all s, I've got 3 s's, so multiply by 3. Here, if we have a square, I multiply the length of a side times 4. So that's what that 4s means. So it's the length of the side times 4, because all 4 sides are the same. Okay. So these are all formulas. All of these equations here are all formulas that if I know the length of a side, I can find the perimeter, because it's P equals. So for part A, suppose you want to write a formula that allows you to calculate the side length S of a regular polygon if you know the perimeter. So we want to find S if we know P. So for an equilateral triangle, the equation is P equals 3 times S. I want to figure out what is S if I know what P is. Okay, so what we can do is we can use our rules for solving, and I want to solve this guy for S. Right now, S is being multiplied by 3. The opposite of multiply is divide, so I'm going to divide both sides by 3. So for an equilateral triangle, my equation would be S equals P divided by 3. Okay, so if I know the perimeter, I can plug the perimeter in there, and it can tell me the length of the side. Okay, so now we want to do that for each of our 4 regular polygons there. So P equals 4 times S for a square. Divide both sides by the 4. S equals P divided by 4. You're probably noticing a pattern there for a pentagon. P equals 5 times, oh, my 5s and my S's. I don't like using S's because my 5s look a lot like S's. 5 times S, divide both sides by 5. The side length equals S divided by P divided by 5. Sorry. And then for a hexagon, which is 6 sides, divide both sides by 6. S equals P divided by 6. So what we did is we just rewrote these equations for solving for a different variable. Right now, all these equations are solved for P. What we mean by that is P is on one side all by itself. Okay, now these new ones here are solved for S. Okay, now those are solved for S. Okay, so a polygon with n sides, so we don't know the number of sides, so it's n sides, meaning we don't know how many sides it's got. It's sometimes called an n-gon. So if something had 13 sides, we call it a 13-gon. What would be a formula for finding the perimeter P of a regular n-gon? Okay, so we want to find, basically, we want to have some hypothetical shape over here that's got n sides. So we call it an n-gon. We want to know what the perimeter equation is. Well, this one had 3 sides, and my equation was P equals 3S. Okay. This one has 4 sides, and my equation was P equals 4 times S. This one had 5 sides. P equals 5 times S. We noticing a pattern? So if I have n sides, it's going to be P equals n times S. Because all of this was the number of sides. These all were the number of sides times S. So P equals n times S. Wow, is that a crazy equation or what? We don't have a single number in that. But all this means is to find the perimeter, I take the number of sides times the side length. This is the number of sides, and this one is the length of the side. Okay. So that was for this first bit. What would be a formula? We just did what would be a formula for finding the perimeter. Next part, what would be a formula for finding the side length? Ooh, I misspelled finding. Sorry, typo, that's not right. You can tell I typed these up myself. For finding the side length S. So basically we're going to do the same principle. We're going to do the same thing as we did up here. And what did we do? We divided both sides by the number of sides. So here we're going to take P equals n times S. We want to find the side lengths. We want to solve it for S. So we're solving it. Oh, sorry, I don't know why that scrolled. We're solving for this S. Right now S is being multiplied by n. So to undo a multiply by n, we divide both sides by n. So S equals P divided by n. N is the number of sides. All right. So next, can you write a formula for finding the number of sides n? So here we want to find the number of sides n. So I want my equation, instead of, we've got an equation that's over here P equals. We have one that's S equals. I want one that's n equals. Okay. If you know the perimeter and side length. So I want one that's n equals. So I'm going to go back to this equation. And instead of solving it for S, I want to solve it for n. N is being multiplied by S. To undo a multiply by S, I divide both sides by S. S divided by S is 1. So n equals P divided by S instead. So there I've solved for n. Okay. All right, we have one more formula here. The formula for the sum of the angle measures in a polygon with n sides is S equals 180. I'm going to write the equation there. S equals 180 n minus 2, where the angles are measured in degrees. What is the formula for the number of sides of a polygon if you know the sum? Right now, this equation is solved for S. This is now solved for S, where S is the sum of the angle measures here. S is the sum of the angle measures, meaning if I take all the angles and add them all up. Okay, so if I take all the angles and add them back up, here's how you find what that sum's going to be. Okay, so now we want to solve it. What is the formula for the number of sides? We want to solve this guy for n. We want to solve for n. We want to get n by itself. In other words, when I'm all said and done, down here at the bottom, I want it to be n equals instead of S equals. Okay, so there's a couple different ways of doing this one. I think I'm going to kind of do a semi-mapping on it. The first thing I do to n, if I knew what n was, The first thing I do to n is subtract 2. So I'm going to write over here, subtract 2. When I'm done subtracting 2, then I divide by the 180. Then I multiply by 180. So I'm going to go ahead and I'm going to do it backwards. You could distribute this guy out. I could distribute this 180 in, but you don't have to. I can just undo the opposite way. So I need to undo the multiply by 180 first. So to undo a multiply by 180, I need to divide both sides by 180. 180 divided by 180 is 1. So my equation ends up being, let's get rid of that down there. My equation ends up being s divided by 180 equals n minus 2. And then I need to undo, well, I'm going to rewrite that as n plus a negative 2. So then I would need to add a positive 2 to both sides. So s divided by 180 plus 2 equals n plus a negative 2 plus 2. That is 0. So my equation, n equals s divided by 180 plus 2. So now if I know what all the angles add up to, that s, first thing I do is divide it by 180, then add 2, and that'll tell me how many sides a figure has. So there's my equation right there. All right, on to task 2. Here we have a garden. Trisha has enough wire fencing to build 30 feet of fencing. So she can build 30 feet of fencing around her rectangular vegetable garden. She wants to use all of the fencing, but hasn't decided on the dimensions of the garden yet. So she doesn't quite know how big she wants to make it. So we know that the garden's perimeter, again, all the way around is the perimeter. So all the way around is the perimeter. And here's our equation for perimeter. Basically, I know if this is a width W, then this is also a width W. If this is a length L, then this is a length L. So if I add W plus L plus W plus L, basically I've got 2 W's plus 2 L's. So I know that has to be 30. So now let's go ahead and let's try some hypotheticals. Let's say we want the width to be 5 feet. So we take this equation, 30 equals 2L plus, and we want the width to be 5, 2 times 5. So 30 equals 2L plus 10. Well, to undo that plus 10, we're going to subtract 10 from both sides. Equals 2L. And then to get the L by itself, I need to divide by 2. So my length then would be 10. So I would have a width of 5 and a length of 10. What if I wanted my width now to be 6 feet? Well, now we repeat, but now we use a 6 instead. 2 times 6. So 30 equals 2L plus 12. Now and I'm going to start using some of the shortcut for solving. Again, notice how I write it. I don't have any lines or equal signs. I'm just showing subtract 12, again, on both sides of the equal sign. Make sure you keep track of where that equal sign is. Okay, 30 minus 12 is 18. Equals 2L, divide by 2. The length then would be 9. So I could go 6 by 9. 6 width, 9 length. Okay, what if I wanted the width to be 7 feet? Okay, repeat the process. 30 equals 2L plus 14. Subtract 14 from both sides. So here we get 16 equals 2 times L, divide by 2. Okay, so my length then would be 8. Okay. If you noticed, in every single one of these, this one, this one, and this one, we did the exact same process. We plugged in the number, and then we subtracted that bit from both sides. Then we divided, in this step, we divided everything by 2 to get to the final answer. Okay, so we just had to repeat the same process over and over and over again. What if, instead of doing that 3 times, we just did it once and then had to solve each time? So basically, we're going to rewrite this formula to express the variable L in terms of the others. So meaning we're going to take this formula and not plug anything in yet. We're going to leave the L and the W, and we're going to solve it for the length. So you notice all my answers here were length equals, length equals, length equals, and I plugged in the width. So now I'm going to solve this for L. So I need to get the L by itself. So my equation is 2 times L plus 2W. So I need to undo this plus 2W first. So I'm going to subtract 2W from both sides. Plus 2W minus 2W. So over here, these add to 0. So I get 30 minus 2W equals 2L. And then I need to get rid of the multiply by 2. So divide, and I have to divide this whole side by 2. If you are not used to using the fraction bar for divide, you're going to have to get used to it. We'll do a lot of practice with it, but we're going to be using that fraction bar a lot. So 30 minus 2W divided by 2. Or I could take these both, basically take both of these pieces and divide it by the 2 and write it as L equals 30 divided by 2 is 15 minus 2W divided by 2 is W. Either way, this one is simpler. Basically, what this tells me is if I know the width, I can very easily find the length. Okay, so I can just plug in. And if you notice, it does work for these equations up here. Because if my width is 5, I take 15 divided by 5, I get the 10. If my width is 6, I take 15 divided by the 6, I get the 9. If my width is 7, 15 divided by 7 is the 8. Okay, so I wouldn't have had, if I would have done this whole process first, I wouldn't have had to do it each of these times. I could just plug my width into this new equation and go from there. That's why rewriting equations to solve for the pieces you want to find can really save some steps. Okay, one way of doing that is by rewriting literal equations. So far, we have already worked with equations containing constants. Again, our constants are numbers that don't have the variable part on it, and variables. A literal equation is an equation in which constants have been replaced by letters. Okay, so one way in which a literal equation is used is here. If you notice in each of these, I have the same pattern going on. It's some number times x plus some number equals a number. Okay, in all of them. Okay, even this last one, if I think of it's 1 times x plus a negative 4. So basically I have 1 times x plus a negative 4 equals 2. Okay, so in all of these I have some number. So we're going to go ahead and replace these numbers. So I'm going to replace these first numbers in all of here with another variable. Let's use an a. So I take a, some number times x, add some other number to it, and I get some different number. Okay. This only works if a can't be 0. A is not 0. Because if a was 0, then this first bit, you wouldn't have an x. Okay, so for this pattern to work, a is not 0. So the way we write that mathematically is we like a is not equal to 0. We write it that way. There's the not equal to symbol. It's an equal to sign with a line in it. So a can't be 0, because if it is, this doesn't work. Okay, so basically we're just noting a pattern here. All of these have the same pattern. Now I could solve each of these individually. Like I could take each of these and solve them individually. I could solve that guy, I could solve this guy, I could solve this guy. But when I solve each of them, I'm going to be going through the same steps. I'm going to be adding same thing to both sides and dividing same thing to both sides. So what we can do is we can take this literal equation instead and solve it for x. And then we can use basically that solving as a shortcut. Okay, show what I mean by that. So first thing to get this x by itself is I need to get rid of this add b. So to get rid of an add b, I need to subtract b or add a negative b. So plus b minus b equals c minus b. There's going to be a lot of crazy variables, but we're all right. C minus b. So this is 0. So then I have a times x equals c minus b. To get rid of the multiply by a, I divide both sides by a. Again, don't ever lose sight of what we're solving for. We're solving for x. So x equals c minus b divided by a. Basically, this gives me a shortcut for solving if it fits the pattern. If it fits the pattern. Okay. So again, our pattern is, this is our pattern. So let's go ahead and let's use that shortcut to solve here. So first I'm going to do is I'm going to write my shortcut down. X equals C minus B divided by A. Now I need to know which part is which. My A from up here is my thing multiplied by X. So my A, so I'm just going to list it underneath. My A here is the 2. My B is the 5, and my C. Because my equation, again, is AX plus B equals C. So there, do I have there's my AX, 2X plus B equals C. Now that I know what my A, B, and C are, I just plug them in. X equals, my C was 9, minus my B, which is 5, divided by 2. So I have to do the 9 minus 5 first, 4 divided by 2. X equals 2. And I can check it. It's always important that we check it. 2 times 2 plus 5, does that equal 9? 2 times 2 is 4 plus 5. Yep, check, it worked. There, I solved it. Just by denoting what my A, my B, and my C were. So next, write the equation. X equals C minus B over A. Write my shortcut. My A, again, is a negative 3 in that case. The negative 3 is A. My B is 1, and my C is 10. So now plug it in. C is 10 minus 1 divided by negative 3. 10 minus 1 is 9 divided by negative 3. So X equals 9 divided by negative 3 is negative 3. Again, let's check it. Negative 3 times negative 3, there's my X, plus 1. Negative 3 times negative 3 is positive 9, plus 1 is 10. Woohoo, it worked. Okay, next one. X equals C minus B over A. This one's a little trickier because it's harder to tell what your A, your B, and your C are. I can tell my C. My C is 2. Okay, I've got that. But I'm going to rewrite this so I can very easily see my A, my B, and my C. The thing multiplied by X is 1. So I have 1X plus a negative 4 equals 2. So my A is 1, my B is negative 4, and my C is 2. X equals C, 2 minus a negative 4 divided by 1. So 2 minus a negative 4 would be 2 plus, the opposite of negative 4 is positive 4. 2 plus 4 is 6, divided by 1 is 6. So X equals 6. Let's check it. 6 minus 4, does that equal 2? Check. So again, this is just a shortcut. So this is just taking, and this is why it's important that we know how to solve literal equations.